Hi, I'm Kian, and today I want to show you how to evaluate a series using the limit comparison test. So you have a series from 1 to infinity of 1 minus cosine of 1 over n. But if we use this series and use a limit comparison test, we won't have a conclusion, because for limit comparison test, we should have a known series that would converge or diverge, and also form a division, and then find a conclusion for the series. But if we use this series, we won't have a conclusion. So, recalling from our trig identities, we can form that sine squared theta is 1/2 times 1 minus cosine of 2 theta. So using this identity, we can say that 1 minus cosine of 1 over n, replacing theta with n, is equal to 2 times sine squared of 1 over 2n. And now we can use 1 over n squared as our known series. So when we check this series from n equals 1 to infinity of 1 over n squared. And because here p is equal to 2, which is greater than 1, this series converge. And now we use a limit comparison test. So using this value, we should evaluate the limit as n approaches infinity of 2 times sine squared of 1 over 2n over 1 over n squared. And now how I'm gonna solve this? So I'm gonna write this as 2 times sine of 1 over 2n multiplied by sine of 1 over 2n, and then all over 1 over n multiplied by 1 over n. And now I'm going to form a substitution. So I let theta to be equal to 1 over 2n. And when we solve for n, we get that 2 theta is equal to 1 over n. And now we can just plug in. So I come here. So what we get is 2 times sine of theta multiplied by sine of theta all over 2 theta multiplied by 2 theta. So we can see that this and this nicely cancels, and we can use our limit rules that the limit of a product is a product of a limit. You can see this limit is a very famous limit of sine of theta over theta, which approaches 1. And also, you can see that if we put this 1/2 outside of the limit, we see that sine of theta over theta again forms this very special limit that goes to 1. So our final answer is just 1/2 times 1 times 1, which means this is just equal to 1/2. And now, because we're doing limit comparison test and we want a positive answer, if the answer is positive or finite, we can make a conclusion. And we should mention that 1/2 is greater than 0. So our conclusion is that the series from n equals 1 to infinity of 1 minus cosine of 1 over n converges by the limit comparison test. Thanks for watching. Please subscribe to my channel and watch previous videos.